In Activity 10, a different kind of magnet, students are first introduced to the fundamental relationship between electricity and magnetism. Students then observe the effect that a wire with electric current flowing through it has on a compass and discover a relationship between electric current and magnetism. You will need the following materials from the kit: Activity Sheet 7, D-cell batteries, battery holders with clips, compasses, square pieces of emery cloth, and enamel-coated wire. You will also need to provide metric ruler and scissors. To prepare for the activity, make a copy of Activity Sheet 7 for each student. Use the scissors to cut one piece of enamel-coated wire about 2.1 meters in length for each team of 4 students. Each team of 4 students will need a battery holder with 2 clips, the piece of enamel-coated wire, a square of emery cloth, and a compass. To begin the activity, place all the materials on a centrally located distribution table. Divide the class into teams of 4 and invite one member from each team to come up and get the materials. Have the students use the emery cloth to sand off about 2.5 centimeters of the enamel coating from each end of the wire. Next, have the students form a loop in the center of the enamel-coated wire by wrapping it once around their finger. Then, place the compass on the edge of a non-metallic table so that the compass needle is perpendicular to the edge of the table. Now have them approach the compass with the loop of wire. Ask students, does the compass react to the loop of wire? They will see that the needle does not react. Next, demonstrate and have the students set up their batteries by placing a battery in a battery holder. Insert the clips between each end of the battery and the battery holder. Press on one clip and insert one sanded end of the wire into the resulting loop. When the clip is released, the wire will stay in place. The section of wire that had the insulation sanded off must make contact with the metal loop of the clip. Next, attach the free end of the wire to the other clip and approach the compass with the loop of wire. Then ask students, what happened to the compass needle when you approached it with the wire loop this time? Most students will be astonished to find that the compass needle moves. Make sure to warn the students not to leave the wire connected to the battery for more than a few seconds at a time, as this will quickly drain the battery. Also, the wire can get quite hot. Distribute Activity Sheet 7. Have the students conduct the test again, but tell them this time to pay special attention to how far and in which direction the needle is deflected or turned aside. Ask them to record their observations on their activity sheets. Then introduce the word deflection to describe the way the temporary magnet causes the needle to turn aside. Ask students, what can you conclude from the results of this experiment? Students should find that the movement of the compass needle indicates that the electric current flowing through the wire created a magnetic field around the wire. Explain to the students that electromagnetism is magnetism that is created when electric current flows through a wire. A magnetic field exists around a wire that has electric current flowing through it. Next, have a member of each team wrap 10 more loops of wire around his or her finger. Be sure that the wire is wrapped in the same direction as the original loop. Then, connect the free end of the wire to the clip to complete the electrical connection and approach the compass with the loops of wire. Remind the students to record on their activity sheets how far and in which direction the compass needle is deflected. Ask students, was the needle deflected farther this time? Students should notice the relationship between the number of wire loops and how far the needle is deflected. Then ask, what do you think might happen if the electric current suddenly began flowing in the opposite direction? Instruct students to change the direction of the electric current by disconnecting the wires from the clips and turning the battery and battery holder 180 degrees. One team member should hold the wire steady to ensure that it does not get rotated or reversed in the process. Have the students reconnect the wires and conduct the experiment again, noting the direction and the amount of deflection of the compass needle this time. Have them record their observations on their activity sheets. Each end of the wire should now be attached to a different end of the battery. Ask students, what happened when you reversed the battery? Students should notice that the compass needle was deflected about as far as before, but in the opposite direction. Tell students that in the next activity they will continue to explore the connection between electricity and magnetism. To conclude the activity, disconnect the wires from both ends of the batteries, but leave the remaining battery setups for use in Activity 11. Return the emery cloths to the kit. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSN Teacher's Guide.